say this side. Just want to confirm one thing that if somebody installed Stata 17, it's in the machine, it will work now. There will be no problem in the during the workshop. Hello,
Yes, sir.
ma'am, am
Yes,
I
sir.
audible? Ma'am, please
Yes, you
confirm.
are.
Now it says Kumar Sajjad this side. Shilpi ma'am. Just want to confirm one thing that if somebody had installed Stata 17 in the laptop, it will work now. No problem with
Surely,
during the
surely it will work. There can be one problem there. Um,
yes,
See, if you any one of you have already have a Stata installed, you should not be really downloading the Stata key and all because it will hinder with your already
no,
installed
no, I
version.
got
That's not
installed.
advisable.
I got installed.
Okay, but what can be the problem with this? Because this one is the latest version. Stata 17 is the older version. So there might be some function which might not be available in Stata 17. But there is also a way to tackle that problem. If we feel, if you have that problem, I'll tell you the way how to tackle that problem. We can
Okay.
install those files and work on that. Okay.
Thank you. Thank you so much. Thank you.
Yeah. Because 17, I don't think is so much behind, but if anybody has a Stata 12, 13 also, it will definitely work that way.
Thank you. Thank you so much.
So, Shilpi ma'am, can we like start the session? I think
Sure,
it's already
sure.
11 p.m., so people may join. Okay. Good morning, everyone. It is my like great pleasure to welcome you all in today's exclusive two-day online workshop on advanced panel data techniques on GMM estimation. So we are honored to have with us Dr. Shilpi Tyagi, accomplished researcher and educator, currently serving as an assistant professor at Thapad University. Dr. Tyagi holds a PhD from IIT Roorkee, specializing in innovation economics and applied econometrics. Her extensive research contributions have been published in esteemed journals indexed in ABDC, Scopus, and Web of Science, reflecting her significant impact in the field of econometrics. She is also the recipient of the Best Paper Award at the National Conference on Business Economics, Finance, and Management, which held in Stockholm in 2016, which showcasing her excellence in academic research. Today, Dr. Tyagi will guide us through the dynamic panel modeling using GMM estimation, providing the valuable insights and hands-on experience and training to elevate our research capabilities and publications. So today's workshop is proudly organized in collaboration with Servicesetu Academics, an initiative of the Servicesetu Foundation, which is established in 2021 and registered under Section 8 of the Companies Act 2013. So Servicesetu Academics is committed to empowering the academic community through information dissemination, skill enhancement, and strategic partnerships. We collaborate closely with the leading universities and business schools worldwide, providing services including strategic outreach, faculty recruitment, event organization, knowledge partnership, membership programs, mock interviews, and CV consultations. So please join me in warmly welcoming Dr. Shilpi Tyagi. So it is over to you, ma'am. Okay. Um, Welcome, ma'am. Thank you, Shireen.
Good
I
morning,
just want
ma'am.
to know one thing. Are my slides visible? No.
No, ma'am.
No. Just a minute. Am I the host, co-host with you? Yes, 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 ma'am. You can share. Okay. Okay, sure.
Ma'am, when I started this Stata, but name and organization initialize license sort of option is coming, and I don't have any information regarding this Stata and all, ma'am.
Okay, sure. Like if anybody of you have those kind of problems, we will deal with it later. Don't worry about it right now. Is my screen visible to you all?
Yes, ma'am.
Okay, sure. So, thank you, Shireen, and thank you, everyone. I welcome you all to today's workshop on GMM Estimation 1. So, before we, start this
session formally and getting into, the GMM estimation, I would like to give you a little background about why this particular topic is relevant for all of us in today's time, and also what we are planning to do today and what we are planning to do tomorrow. Okay. So yes, what intrigued me to present a session on GMM estimation, because I have applied GMM estimation in 3 of my research papers. Okay, and I never thought about it that the model is so trendy or something like that. But I attended many conferences also, and I see that people say, okay, the model is trendy and recent. So, and people also think, academicians and researchers mostly, they think that, like, if you have few problems, like let's say if you have problems of autocorrelation or heterozygosity or endogeneity, you directly just apply GMM estimation and all your problems will be taken care of. Which, if you ask me, is kind of true, but that does not make a perfect use case of GMM. So I thought there is a lot of myth about this GMM estimation. So let's today try to understand it in a holistic perspective. Okay, uh, so that's it. But now, because I also received some of the queries from you people. I was able to answer some, and maybe I was not able to respond to some. I apologize to those now. But those queries coming from people, from chemistry background, from physics background. Okay. So I thought, I'm from economics and econometrics. So I thought, are these people also applying GMM? So I tried to do research on what is basically the trend set in GMM and what kind of disciplines are really using GMM. So when I did a prior search on Web of Science publications using dynamic GMM models during the last 10 years, 2014 to 24, I see, yeah, people say it is trendy. It is actually trendy. Okay, I was not knowing it, because if you see in the last year also, 1,326 papers were published in Web of Science esteemed journals, which were talking about GMM estimation. And if you see this graph also, see the graph is already always increasing. So the
Ma'am,
model
your
is
slides are
really,
not moving.
the model is really popular.
Slides are not moving.
The
You're on
slides are
the
not moving. I didn't move
title
it.
slide. Yeah.
I am on the first
Oh,
slide only.
oh.
Is it changed now?
Uh, I'm not able to see any screen
No.
anymore. There is
No.
No,
black
ma'am, it's not changing.
No, ma'am.
Okay, give me a minute then.
And now it's changing.
Now it's changing, but not in the version of a slideshow. Let me try it again. I'm sorry.
It will not work, ma'am, because more than 1,000 people are associated. I mean, so
Okay.
Maybe, ma'am,
So is
you
it
can just share the whole screen, then you'll be able to.
screen is also not visible for many. It is black
many?
screen,
I
entirely
think
black.
we should wait for 1 or 2 minutes so that all people can join and then we can start so
Okay,
that
okay, fine.
so there be
Should have
no
joined by now, no?
connectivity issue.
Thing.
Slides, I think it is.
So Shirin, you let me know when I should start actually.
Slides if like other people are you start, I think, because otherwise
Okay, it is problem with some of the people. I think
we
those who are
will
joined
run short
take
of
some
time.
time for
I'll
them.
be sharing the recording also if
Okay,
someone
sure.
miss some portion.
Just let me know one thing, Shirin, now.
Yes.
I'm changing the slide. Is it visible, the change?
Yeah.
Yes, ma'am, it's visible. And I
Yes,
also
yes.
request you to start because we have the schedule for
Yes,
11
yes,
to 12.
yes, yes, ma'am. You can please slideshow view, ma'am.
Okay.
Yes,
So
yes,
it is
ma'am.
visible?
And working.
Nothing is visible.
Fine. So Yeah.
Yes, ma'am.
Not taking much of your time now. So I was just saying that the model is really trendy, and the model is also used across various disciplines. It was also, to my surprise, that I see people from physics, people from electrical engineering, people from chemistry, they are also applying the model. I knew that people from economics use GMM model and also from statistics. And if any one of you is from finance background, okay, this model is really relevant in case of finance data. And if you see it here, see, the model is very relevant for finance data because of its dynamic structure and volatility in the finance data case. But you see a scope here. Not many of the finance people are actually publishing using GMM model. So it can enhance your scope to get your published your paper in a good journal if you apply GMM and properly. Now let's move further. What we are going to cover today and tomorrow. Let's say, because I got that many of you are not aware about data regression. So we are also going to cover little bit of fundamentals today. And I'll talk about types of data. Okay, then we will only move to panel data when we talk about other types of data. Then also like 5 minutes about what is basically the regression modeling. Then we will move to dynamic versus static regression model and why you should use dynamic model and not a static model in your particular use case. And then we will talk about types of dynamic model. And tomorrow, this is for today. Tomorrow we will talk about GMM estimation in Stata, hands-on training, and also about interpretation of result and reporting in the research paper. Today also, after I cover this little bit of theory, we will move to Stata and do some basics in Stata, like how to make panel data in Stata and how to do some basic commands so that you can practice those commands today. And tomorrow we are like enabled to start with the GMM estimation and have a good practice session on its various commands. Okay, so now straight away going into the data. Time series data, all of not all of you, but some of you may be aware about what is time series data. Time series data is basically data on a single entity. Let's say uh, price change. Okay, price change of a particular commodity, or let's say gold price change. Okay, if we take it over a pattern of time, weekly, yearly, anything, so this makes your
And the slides are not moving.
the slides are not moving. Does the slide moves now?
Yes, ma'am.
Now
Yes,
it's
Now
yes, ma'am.
I'll keep it like this only. Is it's visible to you all, I believe?
Yes, ma'am.
Yeah.
So I'll keep it like that. Sorry for that kind of disturbance. So this is basically our time series data.
Exactly.
So when we use, panel data, why do we prefer to use actually panel data over time series? Because see, time series data has some kind of assumption that all the time series is independent and identically distributed. Okay, so results can be really biased. Another type of data which is better than, in terms of validity, better than time series, that is cross-sectional data. So cross-sectional is basically having multiple subjects, but at a particular moment of time, at a single point of time. So what it allows us basically to compare the differences among selected subjects, but it has no regard to time. Then we have pooled data. Pooled data is something where we are mostly confused, pooled and panel. Okay, so pooled data is different than panel data. Panel data can be a subset of pooled data. Pool data has when you have a time series of cross sections. Only difference that it has then, other than the panel, that each cross section do not necessarily refer to the same unit, while it is not the case in panel. So when we talk about panel data, which we are going to talk about in today's workshop, is basically it's your longitudinal data or cross-sectional time series data, because it's an interaction of cross-sectional plus into time series. Okay, so what we do when like if you see the example also here, you see firm. Okay, these are the codes given to firm like 1 2 3 4 5 6 7 8. These are years. Okay, and then you have different variables like I capital, I labor, I sales. So you see here for each firm, we are having the same observation. So it involves observing the same entities like individuals, companies, or countries over multiple time period. Okay, So why this data is considered to be better for the validity? Because see, this kind of data has a benefit of heterogeneity, and also it allows us to compare changes over time and across various entities. Okay, panel data can be of two types: balanced and unbalanced. Balanced mean when we have data for all the firms for all the years for all the variables, which makes it a balanced data. Unbalanced data is when we are having the same firm, same variable, but we do not have this data for each variable in the each year for each firm. Okay. And there is also this kind of because this kind of myth I also come across sometimes, that it's advisable to use balanced data over unbalanced data, which is not really true. It depends on your problem and what kind of data is available to you. GMM model, it works perfectly fine with balanced data. It works perfectly fine with unbalanced data. So whatever the kind of data you have, you can really use it to use GMM, and it makes no difference. Okay. It should be dependent on your research problem, not on what is superior or not. So now, regression. Regression, as we know, simply it's sciences, social sciences, we measure two or more variables on the same individual. So what we try to see, cause and effect relationship, what is affecting what, and the functional relationship. So we talk about two things here: y, that is your dependent variable, or we also call it response variable or predicted variable.
Excuse me,
Yes,
I will here. What is functional relationship?
functional relationship. Okay. Functional relationship is basically when we say y is a function of x. It simply means it's caused by that. Okay. Sometimes we say cause and effect relationship. Sometimes we say functional relationship. Let's say we say demand is a function of price. Okay. X is referred to as the independent variable or explanatory variable or predictor variable. So this yx is basically what we use in equation. Y is dependent on x. X is independent, y is dependent. Now, if we talk about simple regression model, okay, we generally believe that y is a linear function. This is our first assumption. Y is a linear function of another variable x. X can be x1, x2, x3, multiple variables. We generally call it x, with unknown parameters beta1 and beta2, which we wish to estimate. So this is how we start our any regression. But we have a simple observation here for four x values. What we think that it will look like this. Okay, it is going to be a exact relationship for q1, q2, q3, q4, but that's not a real case. Okay, real cases we see a lot many deviation, and that is why we um, measure any regression coefficient to understand, okay, what is this basic relationship. So to allow for such divergences, we will write the model as y is equal to beta1 plus beta2 x plus u, which is your disturbance term or error term. So you will see in all the models there is a u term or error term. Okay. So this is basically our simple regression.
I just want to confirm one thing: that error term means that the variables which are not in the model,
Yes.
but they are in the model. Na?
Yes, that is that only. Because you see, like even if you take 14, 15 variables, which I think are like, a lot of variables. But still there can be thousands of variables which we have not taken care of, okay, which are not explained. So this also account for those. But of course that you
Thank you.
basically see by the R square values when your model is estimated. Okay. So you can use the P points to draw a line, which is an approximation to this line. So this is basic regression. Now we move to panel data regression models. Two types of model we mostly talk about, and I'll focus on that. One is a static panel data model. Second is the dynamic panel data model. What is a static panel data model? Where we assume that time points are independent. Okay, they are not dependent on each other, and treat the data as a cross-sectional comparison. Okay, this is our static data. We are taking it one panel at a point of time, and that is how it is measured. without taking any temporal consideration. But when we talk about dynamic panel data model, we consider the time dynamics of variables, especially the time dynamics of your dependent variable, okay? Accounting for the lagged effects and change over time. So dynamic panel data model, as I told you, or if we compare these two kind of a structure, static versus dynamic model, you know, first thing is that first parameter is time dynamics. So basically static model, it ignores any time dependencies or temporal dependencies, while the dynamic panel data model explicitly accounts for temporal dependencies and lagged effects, lagged variables. See, if you ask me, can we use lagged variables in a static panel data model? Yes, sure, you can use, but not the lag dependent variable. Because if you use lag dependent variable in a static panel data model, then your estimates are going to be inefficient. So what you can do, you can instead measure a dynamic panel data model and can use your lag dependent variable as regressors, okay? If we talk about its estimation in a standard panel data, we can measure either the fixed effect or random effect, of course, after applying the Hoshman test. Then in the dynamic panel model, we have specialized methods. We often call it GMM, which is generalized method of movements to address endogeneity issues. Focus here in the static model is basically on cross-sectional comparisons. And in dynamic panel data model, we see how the variable change over time and the impact of past values. So if you see, it carefully and you try to understand it, you will notice one thing. We are talking about panel in the case of a static and dynamic, while a static model is measuring what basically cross-sectional comparison, which makes GMM model is a better use case in most of the cases. I will not say in all of the cases. Okay, we cannot blindly apply it. So now moving to the topic of today, dynamic panel model. This approach to panel data models, it basically involves the use of a dynamic effect. And how do we calculate the dynamic effect? Let's say by adding a lag dependent variable to the explanatory variable. If you ask me what is going to be the value of lag, it can be anything depending on your prior knowledge. It might be lag of 1 year, 2 years, 3 years. Okay. Additionally, this model is estimated using generalized method of movements, which is called GMM. It works in the similar way to two-stage least squares, but which makes it a better use case than two-stage least square is basically overcoming problems of endogeneity. It solves the problem of endogeneity, which is not really the case with two-stage least squares. This approach basically requires that n should be greater than t. That means your cross-section should be more than time series. Okay, this is a very important assumption in case of this module. Now, because I was talking about use case so far, so let's understand what is a proper use case for applying dynamic panel model. So first thing is that it captures persistence and adjustment. Okay, and it partially adjusts. We also called it partially adjustment model or error component model. So basically, when the dependent variable's current value is influenced by its past realization. Okay, so what we have here, we have that the model is persistent, okay, or adjustment of the variable of time. For example, if you have, try to do a review of literature or search the paper, let's say in profit and all. In profit, I see a lot of papers which talk about profit persistence. Okay, so when you have to talk about persistence, first thing is that you will be using mostly a dynamic panel model. And if you have to understand it in a better way, I'll tell you. For example, R&D. Okay, if you are working on any of the determinant of R&D, which is research and development expenditure, okay? So R&D, if you understand, because all of you work in the field of research, any year's R&D is basically dependent on previous year's R&D, or let's say last 2-3 years R&D, okay? Why so? Because See, if you do not have a established R&D infrastructure, you cannot really do R&D. First, you need to establish it. Okay, like the lab, you have to hire a skilled staff and have to have a prior knowledge for that. So R&D models, if you are estimating, better use case is a dynamic panel model. Of course, many people don't use it because there is another problem with R&D module. That is the problem of limited dependent variable model. But if your dependent variable is not limited, you can directly use dynamic panel model. Yeah, or you say exports. Exports also, it also require a kind of established facility. So for export, you really need to have exports in the previous year. Okay. So it also has that kind of persistence in the model. Okay. And if it is a partial adjustment process, the coefficient on the lag dependent variable measures the speed of adjustment. That is 1 minus coefficient is speed of adjustment. Okay, one thing I want to make clear here. See, even if you see that in dynamic panel model, the first thing that we do, take the lag value of dependent variable. It doesn't necessarily mean that we need those values in the model. We need to, really focus on those values. But we have those values to capture the persistence. We necessarily do not talk about those values, but it changes our model structure. Our estimates on any of the variables, captures the effect of persistence in the model. Also, if there is an endogeneity, okay, and this model is a better version, better, extension of, let's say, IV model. So it's better to address endogeneity by using dynamic panel model. By including lag dependent variables, dynamic panel models can help address potential endogeneity issues. Okay, you even don't need to check for endogeneity, though you can really check for it if you want it. But if, like, you think there is going to be any potential endogeneity, you can use a dynamic panel model where the dependent variable might be correlated with the error term in a static model. So it solves for that. Now, what is basically the dynamic process? Dynamic panel models, they are well suited for studying dynamic processes where the dependent variable is influenced by its own history, such as economic growth of any economy, any type of investment decision, or behavioral change. These are all dynamic processes. Sometimes we think, how do we know our, dependent variable is dynamic or not? You know it by the prior knowledge. Hai na? There is not like any validation test to know if we have the dynamic process or not. You will know it by your theoretical background and prior knowledge in your discipline. But it also accounts for unobserved effects. So dynamic panel models can also account for unobserved or fixed effects that might be correlated with both the lagged and current value of the dependent variable, which is basically solved by GMM application. Now, because when we talk about GMM, we really see a lot of discussion going on internal instruments and external instruments. So I thought many of us are not clear about what is an internal instrument, what is an external instrument. So it will really help you to include both of these instruments here. Internal instrument are basically lagged value of the endogenous variable. By endogenous variable, we mean most of the time lag dependent variable or other variables within the model. It's not like you only have to have, lag dependent variable. You can also have independent variables there as internal instrument. Elano and Bond and Blendon and Bond, they are well known for using internal instrument in their GMM estimation meters for dynamic panel model. Okay, that is why this GMM model is also known as A and B estimator. So the strength of internal instrument can be affected by true parameter values of data generating process, potentially leading to weak instrument when the lag dependent variable coefficient is close to 0 or 1. So if see, any of you who has not studied internal instrument or external instrument, it might be a little bit difficult to process right now, I understand. But I'll also tell you, its practical use case when we apply GMM model. I'll tell you what can be an internal instrument really, what can be an external instrument, and we will apply it. The use of internal instrument also sometimes create a major problem, that is a large number of instrument potentially causing use issues with identification and efficiency. So you really need to know what is your internal instrument and then only apply it. Okay. Now external instrument. These instruments are basically variables that are more not part of the model, okay, but are believed to be correlated with the endogenous variables. Suppose sometimes we think this variable, this particular variable, is not really the determinant in my model, but I still need to use it because it is anyhow uh, impacting the variables in the model. For example, if there is a model of investment and government policy changed, it can be used as an external instrument if it is believed to affect investment but not the adder term. Or for example, there is like you know some crisis here is there in your data, you can also use it as an external instrument. Okay, maybe you were not earlier planning to use it as a variable because you are not sure if it is going to impact your estimate or not. You use it as endogenous, if you use it as external instrument, your estimates are going to change and you will see its impact. Okay, and it will also address your potential endogeneity issues which cannot be addressed by using internal instrument alone. So if you have in mind any external instrument, you should use it. And also when you use it, it can improve the efficiency of GMM estimator, but it is important to ensure that the instruments are valid and they are uncorrelated with the error term. So for that, you will do a post estimation of validity, which I'll show you. So if we try to define dynamic panel data model, basically you see this kind of equation we use, like YIT, Y here is our dependent variable, then we have its first lag by T minus 1. Okay, Shruti. Shruti, do you have a question?
Shruti, you can turn on your mic now.
Yes, ma'am. Good morning. Actually, I wanted to know the assumption you talked about, like n has to be more than t. What does that actually mean?
Okay, that simply means there are observations which we have by n, like the number of variables. Let's say I'm talking about R&D observations for 10 firms. Okay, so if I have R&D observations for 10 firms, so it should be greater than number of years. So like if my years are 5 and R&D observations are for 10 firms, it makes it a use case for GMM. We will understand it better, but I hope you get an idea. Shruti, is it clear?
Yes, got it, ma'am.
Yes, ma'am.
Okay. And what about you, Shahzad? You also have a question? Shahzad.
One question is that suppose dependent, if we are taking lag of dependent variable, then we have to go for dynamic panel. But suppose the lag of independent variable.
Sorry to interrupt, but your voice is not really very clear. Yes.
My question is that if I am taking the lag of independent variable,
yes,
not the dependent variable. So can I go for dynamic panel or simple static model?
you can of course go for simple static model. There is no use of dynamic model there. But if you also have to account for lag of dependent variable, you have the lag of dependent variable plus lag of independent variable, then only you can also you can use GMM model or any dynamic panel model. Okay.
More one question, ma'am.
Yeah, sure.
Suppose endogeneity issue is there.
Yeah.
If endogeneity issue is there, so I have to go for dynamic because in order to short it out.
Yes. There are other alternative also to GMM if you really don't want to apply it. But if you have an issue with endogeneity and you don't know much about econometrics, you can blindly go for GMM. But first thing that you should have in mind is basically your model has dynamic structure, that there is some persistence in your model or dynamic process. Otherwise, it is not going to help you. But endogeneity issue basically arise because we have that time persistence. Okay, so you can go for that.
Ma'am, one more question.
Yeah,
So
sure.
how to find out an endogenous, whether the independent variable is endogenous in nature or not? So
There are
in
different tests. There are different
afterward,
tests.
yes, but
Yes.
that little bit we will clear that in coming class.
Yeah. Yes, sure. Don't worry about it.
Thank you, ma'am.
We are actually going to do those tests tomorrow. Okay, I'll show you. So in any case, I
Sure.
have planned it, so I'll show it. Okay. When we
Sure,
when we
ma'am.
start
Thank you.
estimating those tests. But one thing is clear. I'm telling you, you don't really need to go for endogeneity test. But yeah, sometimes I understand, because when you are applying a static model and then you see endogeneity in your variable by applying endogeneity test, then you need to move to dynamic model. So I'll show it. Yeah, Muzammil, ma'am, how to know that there is an endogeneity in our data? I'll tell you, don't worry. Okay, there is a test for endogeneity that we can really apply. Okay. Who else is there? Just a minute.
Shilpi ma'am,
What type of data? Yes.
like Sabha is right. Actually, I'm thinking like, can we take all the questions at the end so that like if someone have already known this, they can, for the sake of
There is no problem with me if we take it now, if we take it later. So yes. Okay.
Fine, ma'am.
Because when we
So we'll
move to
take it-
status, yes, sure.
Yes.
I'll take it later.
Yeah.
So any of the question I'll take later. Don't worry about it. Okay. Anyway, we have just, I think, 10 minutes left for the presentation.
Yes, ma'am.
So
Yes,
all of
ma'am.
you-
Then we will start taking
Yeah.
one by one. Yeah.
Yes. So all of you can kindly wait for that time. Okay. So basically, you see here, we have the lag dependent. Are the slides visible to you now or not? First thing.
Yes, ma'am. It is visible.
Okay, fine. So first thing you see, first variable that we have in the independent variable is the lag version of dependent variable. Then we have xit, alpha. So for if you see here, basically, we have all the terms like error terms, okay, random error component. So this is how we write a dynamic panel data basic equation. Okay, x here account for all your variables. You can have x1, 2, 3, 4 till xn. Okay, and then one interesting thing that many people they know but they don't talk about is basically dynamic panel bias or nickel bias. Okay, so nickel bias basically is a downward bias which arises in low T panels where time is low. Okay, and when you have such kind of panel where your time is low, there is going to be and it originates from the connection between the lag dependent variable and the fixed effect. Okay, so when there are short-term fluctuations obscuring the long-term trends, we have this nickel bias. And to solve this nickel bias, basically, Elano and Bond has come with this dynamic panel approach. Okay, so nickel bias is one of the background stone in the dynamic panel model development. Okay. Now, what is basically the panel data approach? First thing is that we usually, if we don't, follow the literature carefully, we often say that dynamic panel data model is developed by first Elano and Bond, which is not really the case. Okay, they only popularized the work of Holtz, Ike, Nuse, and Rosen of 1988. Okay, and they developed it further, and that they say that the instrumental variable approach noted in their 1988's work does not exploit all of the information available in the sample. So what they did, they said more than the IV approach, we should go for generalized method of movements because it is going to give us more efficient estimates of dynamic panel data model. So this is a little bit of background in the development of the model. So when we talk about, dynamic panel model, we often come across these two terms: difference GMM, system GMM. What you will see mostly people applying system GMM because it is considered to be the better version of difference GMM. It's an extension of difference GMM. But in some particular use case, you can also apply difference GMM. Now, difference GMM basically talks about or addresses fixed effects in dynamic panel data by first differencing the data. And you don't need to difference it yourself. This is basically a part of the model structure. And system DMM, they augment it by estimating simultaneously in differences and labels. So it uses differences plus label, which basically lead to improving efficiency, especially when you have some weakly exogenous variable or dealing with persistence. So even if you cannot decide which one to apply, you can directly go for system GMM. There is no problem with that because, as I told you, it's an extension of difference GMM. Now, Arlano bond or difference estimator, it's basically dynamic panel data model. And this says the unobserved panel level effects are correlated with the legs of dependent variable, known as Arlano and bond estimator. The estimator is designed for data set. One thing is that a lot of you were having this query. I can see it in the written form that if you have many panels and few periods, okay, and there is no autocorrelation in the idiosyncratic error, then you can use this model. And some of you were worried about if I have, more period than my panel, which, if you ask me, rarely happen in case of your data. Generally, we have more panels and few periods. But if that is not the case, you cannot really apply GMM model. You have to go for other model. Okay. Now, these are the simple commands that you can use in Stata, which we are going to talk about. And like analog bond estimation of Y on X1 and X2 using XTstat data. The command is called extra bond. Okay. And now you see a various version of extra bond, one-step estimator, and then the two-step estimator. Generally, you will see people using two-step estimator because it is more efficient than the one-step estimator. And it's also an extension of one-step estimator. Okay. So yeah, I was talking about one-step versus two-step estimator. So basically, two-step estimator is efficient and robust to whatever patterns of heterozygosity and cross-correlation in the sandwich covariance estimator models exist. So historically, when there was no two-step process, people were using one-step results only. Okay. But there is a particular application, okay, which was called WinMaya application, which WinMaya has developed in 2005. This has greatly reduced the problem and it has accepted as an extension to the one-step process. Okay, I'm just trying to clear all your doubts firsthand before you get into the estimation, because these are the kind of doubts that you have, whether to apply difference GMM or system GMM, whether to go for one-step or two-step. Okay. Now, talking about system estimator, which is also known as Arlano Bower or blender bond, because both were doing this kind of development around the same time. It basically fits a linear dynamic panel data model where the unobserved panel level effects are correlated with the legs of dependent variable. This model is basically, as I have told you previously as well, is an extension of the Arlano bond estimator. And it accommodates large autoregressive parameters and a large ratio of the variance of the panel level effect to the variance of idiosyncratic error. Okay. And this estimator is designed for data set with many panels and few periods. See, this is the condition that is coming from, n greater than t from the previous thing. So this is one thing that you have to always take into caution, that your t is lesser than your n. It also requires that the panel level effects be uncorrelated with the first difference of first observation of the dependent variable. Now, how to choose? Okay. Difference or system GMM specification. First thing is that rule of thumb 1 given by Blundell and Bond in 1998. If the dependent variable is in an equation is persistent and close to being a random walk, then difference estimator uh, is giving you biased and inefficient estimate. You will ask, how will we know whether it is this or not? We know it by running post estimation command, and there are other methods which I'm going to talk now. But in this case, it is advised that you should not use GMM difference estimator, but the system estimator. And then we have the second rule of thumb, which say, okay, it's basically the process that the bond is telling us how to understand what to apply. First thing is that he says that initially estimate pooled OLS or fixed or random effect approach, then apply the difference GMM. And if you see your difference GMM estimate is close to or below the fixed effects estimate, then there is a downward bias. And what is the downward bias that I was talking about? It's basically your nickel bias. Then you know, because of weak instrumentation and a system GMM should be preferred. Okay. So use system GMM if your variables are exhibiting a random walk. So how do you know it is a random walk? By applying this point. If difference GMM estimator is basically close to or below the FE estimator, then the real use case is for GMM module in the system estimator. Now, we talk about post estimation also. Okay, what are the tests? There are not, like, if you ask me, there are not much pre-estimation test, but we do post estimation test, because first we have to apply GMM, then we will be doing those tests. So test for over identification restriction or validity of instrument. Either you can apply Sargent test or Hansen test in this case to assess, or you can apply both to assess whether the over identifying restriction, which is your movement condition, are valid or not, or seeing your instrument are truly exogenous and uncorrelated with the error term. Many of you were asking, how do we know whether it is truly exogenous or not? You will know by the Sargent or Hansen test. Then you can also run a command for serial correlation. Okay. And of course, Stata automatically reports for Wald-Chase square or F-ratio test, so you can understand the joint significance of the model. So these three tests, okay, you need to apply for post estimation for your diagnosis. Additionally, because so many of you were interested in estimating the endogeneity, you can actually apply Hoshman test for it if you need it. It's not really needed if you think of only using GMM. You don't need to apply it. But if you are not sure about GMM or static, then you can check for Hoshman test first. Now, this brings us to the end of this, theoretical discussion. So these are the references. I think any one of you who is going to use GMM model should first go through these papers. These are the original papers, and they talk about really the development of the model. So now what we are going to do is basically Stata's basic. First thing that we are going to learn today is how to basically start working in a Stata. So this is how I have planned it. But if you have certain other queries, so we will also, do it. The first thing is that I think open a file, import a file, make your data panel data, because if you really don't know it, it creates certain problems. Then summarize your data, see how graphics work, and also we will see how we can run GMM from the drop-down menu today. Tomorrow we are going to talk about various commands in GMM, which I will also give to you in a do file. So in case you don't remember, you can run that do file, later on and apply GMM. Also how to make a log file, and then about help version in Stata. So this is about it. I think I'll take the question even after we do all of this. Is it okay?
Yes, ma'am. Yes, ma'am.
Okay, fine. So all of you also please start opening your Stata. So is my screen visible to you? Okay, fine. So I shared a file also, a data file. Did you get it?
Yes. I have shared the link in the chat box. You can.
Okay. Okay. So
download
we will
it.
be really using that data set. We will go really slowly. I'll first show you the command, then you can also apply those commands so that we are together in this. Okay. And if you think that something is not clear, you can just let me know there. Okay. So first thing is that, yes. So now we begin with the Stata. I have already run the command so that it is easier for us and we don't lose much time. But when you open your Stata, I'm sure you will see a clear screen, right? Have you opened your Stata interface? Please open it. All of you, please open your Stata interface, because when you open, then you will be able to understand. Where is data? Data is in the chat box. I'll tell you how we can import data. First thing is that you need to just, open the Stata. So now data file is there. Okay. Just take 2 minutes, see that data file first, and then, come to Stata.
It's a CMI file.
Yes, it is a CMI data. Asking for license. So the license key is already shared with you. That license is given. And if you have read that file carefully, you were supposed to, use that link and download it and use the key given to you and then change the password. I hope that you have done it. If you haven't done it, maybe you can do it later on, but right now focus on this. Yeah, in the PDF file, it is mentioned about the key.
Yes, ma'am. We have already mailed in advance.
Yeah,
Along with the training.
sometimes people don't read it. So yeah, what about you, Mohit?
Ma'am, I didn't receive any PDF file. Even I was never invited before this session. So kindly please email all the PDFs and required data for the session.
Okay.
Yeah, just give me 1 minute. I'll share it here only so that if someone do not have the
in the meantime, if anyone of you has any question, I can take it.
Ma'am, please share. Will you please share the slides to us?
You will have a recording, I think so.
Yeah. Yes, we'll share the recording now. Yeah, till the time, if you want, we can have the queries and we'll by the time.
For people who have no problem in downloading the Stata and accessing the data file, if they have any query, please ask.
Good afternoon, ma'am. Ma'am, you said that when you are using static model, we usually don't use the lag DB. But in a lot of finance, I am from a finance background, I've seen in a lot of papers also in static model, they have used the lag DB as one of the independent variables.
Simita. Okay.
Yes.
Yeah. Just let me understand your question properly. Okay. Tell me.
Ma'am, I think
no. I'm repeating it. You just tell me if I am getting it correct or not. Okay.
Yes, ma'am.
So, Simita, you are saying in the finance, you have seen many people using lag dependent variable in the static model structure. Is your
yes.
It's not right. It's wrong. Nobody can stop you. If you ask me, nobody can stop you in using that. Okay. But it starts the problem of instrumental variable. Okay. Because even if you are taking it, you just think. Sometimes people try to, when they are building their theoretical framework, they think that the lag dependent variable is their independent variable. But lag dependent variable cannot be really your independent variable, because it does not. In any case, if you know one thing, if you use it like this, it's going to have you are going to have a problem with multicollinearity first, because those both are related.
So high VIF we'll have.
Yes.
Okay.
So then you have to do some modification. But in any case, if you ask me, it's not an econometrically correct way to use your leg dependent variable in a strata structure, because that is not a static structure, and model is really available. So you should not be doing it. Okay.
Okay.
If you
So
have
ma'am,
that
if I
kind of
that my
yes,
dependent variable is persistent and it's having a random walk,
yes,
and I'm
yes.
using it lag dependent variable, then it's better to go for a dynamic panel model.
Yes,
Right?
and that is why, Simita, I have also told it in the beginning, if you ask me, when I was showing that first slide. And in my mind, if you ask me, I have also worked on finance variables on profitability. I have done a lot of work on profitability analysis. Okay. So in my mind, if you ask me where GMM model is more suited in the finance models.
Right.
Okay?
Absolutely.
Yes. So, but when I have shown that people using in the finance paper GMM model, they are really limited. So maybe sometimes they are not aware about it. Okay. So that may be the case. So there is a lot of scope for you if you apply it correctly.
Yes, ma'am. I am
structure.
going to use two-step system GMM. So that's the reason I got some doubts. So I'll clear it through this workshop. I hope my doubts are cleared.
I hope that your doubt is clear.
Yes,
You
yes,
know
ma'am.
that.
Yeah,
Okay?
yeah. Thank you, ma'am. Thank you.
Anyone else?
Shilpi ma'am.
Yeah, hello. Can I ask?
Yes, Shireen.
Yeah, we have queries like hand raised, so I'll take it one by one. Otherwise, it will be a chaos. No?
Okay.
Just raise your hand. I'll take it one by one. Just do not lower your hand. And now I'll call the name and we'll take the query. If that is fine. So I'll just open the mic now for every. So our first one we have is Shruti Bansal. Shruti, like you can unmute and please ask your query.
Ma'am, my query was already cleared earlier.
Okay. Yeah, I have taken her query as the first one.
Okay, so I'm lowering that. Next is Mohammad Mujahid Khan. Sir, please.
Yeah, yes. Thank you, Dr. Shilpi, for such a nice presentation. So I have just two quick questions. One is like in a condition where in the model, if I have a independent variable, that is not a lag of the dependent variable.
Yeah, sure.
So can I use it as an internal instrument?
Yes, you can.
Okay. Second
And
thing,
it is also clear in that special particular slide where I have
B dash x xt.
Yes,
so
yes.
Yeah, that could be regressed, but I was wondering, could it be used as a particular instrument also?
Yes, it can be.
Okay.
But
Thank you.
if you ask me further, I'll tell you. If you think if it is a valid as an instrument or not, you will know it by after applying validity test. But you have to apply it anyway after estimating your model. Okay.
Perfect. Got it. Second, just a quick question.
Yeah, sure.
What is the difference between nickel bias and endogeneity bias? Are they same, or is there any subtle difference between the two?
See, if we talk about endogeneity bias, it can be downward, upward, both. But nickel bias is basically downward bias. Okay. So it is also given in the slide. It is clear. Maybe if you go to the recording later on, you will see it. Okay. Yeah. Next one, please.
Next is Arpita Sharma. Please ask your
Yes,
question.
Arpita.
Yes, ma'am. So I have a related question to the previous
Yes.
question that so when you are coming up with this instrumental variable, how do we actually identify it? We can test it once we get it, but then how do we get it? Is it coming from the model or some extra variable which we need to take it?
I know that is going to be a confusion with a lot of the people, and that is why I really, included this in the presentation, because sometimes we don't know. We are going to have this doubt later on. Okay, so instrumental variables. How do you know about it? You know about instrument variables from the prior theory. That is first thing. But from the prior theory, it will not be clear whether it is valid in your case or not. You will know it by, post estimation. Post estimation is really the diagnostic test, but it cannot be used as pre estimation because it cannot be applied before running the tests. So you can see that, okay, this is going to be a post estimation. We are getting this estimation after applying the GMM. Okay. But in that case, you can go back if you see that your instrument is not valid. Okay. It shows you result for all the instrument and you will know which one is not valid. You can run your model again. Okay.
Okay. Okay. And because I have never used GMM as such, I've used static
Yes.
models in the past. So when we go for this one step and two step, how is the differentiation that how we move from the first step and second step? What is the relevance of it? Any use case?
Use case. See, I have actually explained it very clearly. Okay. First thing is that. But if you ask me, like if you don't have much knowledge, as you were telling me, okay, and you have to apply, you have to think whether to go for system or difference. You can easily go for system because system is a development of difference GMM. Okay. System already has difference incorporated in it, and then it is going one step further than that. Okay.
Okay. Thank you so much.
Welcome.
Next is Aishwarya Jose.
Ma'am, actually, in my model, like I'm so new to this panel data.
Yes.
And in my model, that there is no lag dependent or independent variable. But when I test for this causality, it is showing a reverse causality. That is like my dependent variable is causing my intern is causing my independent changes in my independent variable. So whether there will be an issue of endogeneity, like should I go for static model or dynamic model?
Ishwara, your case is also, I'm not also getting a proper answer to it. Maybe you can send me an email later. I'll see it and explain it to you tomorrow. Okay. I'm not very sure about it. But if you ask me, it does not make it a use case for GMM model. That I'm sure about. Okay.
Okay. Okay. Thank you so much.
Welcome.
So next is Seema Rani Meher. Ma'am, please ask.
Yes, ma'am. My question is, ma'am, in static panel data model, if the result get the random effect, after that, what can we do?
If in the static panel model,
Yeah.
yes, tell me.
In the static panel model, if the result will get random effect, not fixed effect, then after that, what can we do?
You will apply random model then.
Only random model.
Yes, but
no further model will be applied.
Yes, but Seema, first thing first, for fixed effect, random effect, first you need to have the test for the fixed and random effect, that is Hoshman test. See, if you don't have any persistent problem, if you don't have any endogeneity problem, if you don't have any dynamic process, you will go for a static model, of course. You don't need to move to GMM. Okay?
Okay, thank you.
Welcome.
Next is Garima Gupta.
Hello, ma'am.
Hello.
Yes, ma'am. So my query is that can we use system GMM if our dependent variable is limited? For example, if we have a bank
I am
statement.
understanding what you are saying, but explain it further. Yes.
Yeah. So if we have an index value as our dependent variable, can we still use system GMM?
Tell me one thing, which I'm not very clear about, because you specifically mentioned if your dependent variable is limited. What do you mean by limited dependent variable? I understand what it is, but your meaning is not clear to me. Please.
Limited in the sense that it is lying in a certain range.
It is lying in a certain range. For example, you are saying it's a use case for Tobit model?
Yes, kind of.
Then you have to use Tobit model.
Okay, but I have seen one or two papers where. Yeah.
Give me a minute, Karima. Sorry. You have seen, because if you have joined earlier, I have already explained it. In some cases, if you have limited dependent variable model, so GMM structure cannot help you there. But if you really want to use, there are alternatives to it. Rima, please wait. There are alternatives to it. First thing is that you want to see the dynamic structure, but you cannot do it that way. Then you have to have all the ear effects in that model. Second thing is that sometimes when you have limited dependent variable, so maybe you need to I cannot say modify data structure because we are not going to really modify, but you only make a panel data on the basis of the data which is available for the dependent variable, not really making your model as a limited dependent variable, but a normal dependent variable. Okay.
Okay. Thank you, ma'am.
Welcome.
Okay. Next is Ananya Dikshit.
Yes, Ananya.
Hi, ma'am. Am
Hi.
I audible?
Yeah, sure.
Ma'am, I have a dependent variable in the lag form also, since it is inequality. So I have it in the lag form. Now, but my cross sections are less and time values are more, time entities are more, number of years. So GMM is not.
Sorry, Ananya. Can you really elaborate what it is? How your
Actually,
time is more?
in my model,
Yes.
I have lagged dependent variable, but
Yes.
my cross sections are less and time values are more. Number of years are more.
I'm understanding, but yes.
So in that case, since you have told that GMM is not for the cases where cross sections are less and time values are more. So in that case, what shall I do? Since it is a case of dynamic situation.
But Ananya, first thing I want to know, okay? One thing, maybe it is not clear to you. When you are saying your observation, do you really mean your observation? Or you are just thinking about your variables? Because it's about observation, cross-sectional observation, not your variables.
No, I'm talking about the observation, the states which I'm using, like the particular states which I'm using.
Okay. So Ananya, now understand. State into variables. Okay. State into variables. Is it greater than t or not?
Number of states, ma'am, please repeat.
Yes. Number of states into number of variables. Is it greater than t or not?
No, it's less than that.
Number of states into number of variables. Okay. So I am now also interested to know one thing. How many variables do you have?
States are 10 states are there. Okay.
Yes.
And time of years are much more than 10. It's like.
Yes. Ananya, now.
Dependent variable is just one. Independent. And independent variable
is just one. Okay. Then you cannot apply it. There are other options for it. Okay. But I haven't really applied those, models. So I cannot be, but there are models. You can go for cross-section dependence, IV approach. This is not the use case for it, in your case.
In this case, we can't use GMM.
No, because it will be your inefficient estimate and there will be question raised on it.
Yes, Muzammil is asking the same question, that he has 24 years and
I understand, but in your case, you said you have only one independent variable. So Muzammil, maybe you have more independent variables, so your question may be different. Okay.
Yes, I have one independent variable.
So
only.
your case is very different. Otherwise, it does not make really that sense. But you have only one independent variable. Why are you calling it?
Like I can tell you the exact
it's a time
situation.
series model. It's not a panel data model.
No, I can tell you the exact situation. I am taking inequality as the dependent variable, and
you can also do one thing, and not to waste time of others. Also, you also mail your query, like your data maybe in a snapshot. I'll see and I'll tell you. Don't worry about it.
Okay.
Okay. Now we will move further.
Tomorrow also we have sessions. Maybe the rest of the queries we can take up tomorrow if something is not answered today. So you can mail and definitely will reply on that. So next is Sandeep Singh.
Yes, Sandeep.
Hello, ma'am. Ma'am, I was having one question. Now, I was working on panel data. Like I just recently started working on it. So, ma'am, I have more than 50 variables, ma'am, like in my data.
You have more than 50 variables. Okay.
Yes, ma'am. So problem was like that make a perfect use case for resolving the issue of endogeneity. So,
okay, sure.
Ma'am, problem is like, ma'am, I was working in cryptocurrency. So the literature is like growing, like it's not on a like maturity stage.
Okay.
So not much paper are there who have solved the issue of IV problem in there. So through literature, I wasn't getting any idea about IV, selection of IV for that. Ma'am, for 2SLS as well, GMM, we need some IV. So ma'am, could you please like suggest something about it, ma'am?
I'm not very sure, because if you ask me 50 variables, it is a case, it may be a case, है ना? It may be a case for over specification of model. 50 variables are too much. Maybe you need to limit your variables.
Actually, ma'am, I just started working on it, so I was just
I understand.
all the
When,
causal.
yes, I understand, Sandeep. When we are in the initial stage, we are often fascinated by number of data that we are generating through various variables, and we think of using it all, but it makes it over specification. Okay, maybe you need to limit your variables. 50 variables are too much to use in a model, if you ask me. Okay, so and if you really have, let's say, 30-40 variables, then you have to make indices. You integrate 3-4 variables into one, then you will have, you will have a solution for the problem of over specification. So yes, your problem is different. Okay, you need to work on your conceptual framework.
Ma'am, actually, I had tried with PCA and PLSR regression to make indexes. Ma'am,
No, I understand. I understand. You can even apply GMM. But I'm telling you, your problem is of theoretical framework, not of model. Model will be applied. It will give you result, but it will be over specification. Okay. Next one, please.
Yeah, next two queries we will take now, then we'll move for this data. So one will be of Miss Rekha Kichar and another will be of Aniruddha Ghosh sir. So like Rekha, please, you may ask your question.
Hello, ma'am. Ma'am, how do we decide the exact or right lagged period when we are talking about the lag dependent variable in our model? Hello?
Sorry.
Am
Sorry, I
audible,
did
ma'am?
not get off part of your question.
Ma'am, like in the literature, I found like 1 year lag, 2 year lag, and 3 year lag.
Okay.
In dynamic panel data.
How do you
Decide.
know which one is to use?
Yeah, ma'am. Like 1 year, or 2 year, or more than 2 years, like that, ma'am.
I'll tell you. See,
yes.
There is no clear answer to this in literature. Okay.
Yeah.
Yes, I have also faced this kind of issue when I was a research scholar. But
Yeah,
if
ma'am.
now you ask me how to go for it, okay, then that time I was also confused. But this time I'll simply tell you, see, any model, okay, whatever we apply is not like we just apply it on one day. So you can do your trial and error and see which leg is actually relevant for your model. Okay. And also, you are saying some people are using 1, 2, and 3. So it may be different for, let's say, different context. Okay. For example, I'll tell you, I was using R&D data of Indian pharmaceutical firms. So in my case, even 3 years lag is more than sufficient. Okay. I have used 1 or 2 years, but my paper or my data is not exactly comparable to, let's say, data on Swedish pharmaceutical firms. Their 1 year lag also matters because they are really into the process. So how do you know it? One thing is, if you know your data, first thing is that before applying anything, any model, you need to know your data well. Okay. And you will know it yourself. That is first thing. Second thing is that I have told you, when you are confused, you can do trial and error and you will know about it. Okay.
Yes, ma'am. Okay, ma'am. Good.
So last one
And
is
ma'am,
Mr. Aniruddha
one
Ghosh.
another question, ma'am.
Yes.
Ma'am, how do we decide this particular variable will be we use as a instrumental variable?
How this particular variable will be used as instrumental variable. This will be coming from your theory. Okay.
Okay.
But I have also given you an idea when I was telling. So maybe if you go back to the recording, you will see it. Okay.
Yeah, ma'am. Sure.
Ma'am, one question related to this.
Hello,
Yes.
ma'am.
Yeah.
If ma'am the instruments are not valid, then what should we do?
If the instrument are not valid, see, when we do the post estimation, okay, so we will know which instrument is valid, which instrument is not valid. So we really need to re-estimate it again with a valid instrument. Okay.
We need to take another instrument.
No, not like that. Let's say you have applied 4 instruments, okay, and then we do the post estimation on instruments. Then we will see you know, like if all of your instruments are valid, if some of your instruments are valid, so which instruments are not valid, you can leave them and re-estimate the model again. Because I'm telling you again and again to all of you people, it's post estimation, but this post estimation is your diagnostic test. Only thing is that any estimation, any diagnostic test is going to happen only after post estimation, because GMM use a very complicated kind of model structure. So you cannot do it before applying the model. Take it as a, in your mind, you should take it as a diagnostic test, as a pre-estimation test, where it is really you are going to apply it is post-estimation. So see how you work when you are doing any pre-estimation, something that is not valid, you are dropping it, okay, and using the valid one. So you use the same thing, same practice in this case, okay.
Madam, I think when we get the instrument variable from the prior literature and there is only one instrument variable, then we
no, you do not get it validated by only by the literature, you also get it validated by your model. Basically you have to get it valid by your model. In literature you are getting the prior knowledge, not literature is not telling you is it going to be a real valid instrumental variable, okay. Next one please.
Hello.
Yeah,
Hello, ma'am.
I think this
Yeah,
is the
ma'am.
last one.
Ma'am, I'm
Yes.
working on actually bankruptcy prediction modeling. So
Which one? Sorry.
in bankruptcy prediction modeling.
Okay.
And I'm working on panel data, which have number of forms is 226.
Okay.
And time period I have taken 10. And
Okay.
I have shortlisted around 13 important variables as per their
Okay.
importance score. So can we apply GMM model on that?
Yes, you can. All the
And
best to you. If your panel has dynamic stock process.
Yeah, I want to, you can say, present a dynamic, you can say, model
Yes,
for
yes.
that
You
only.
can-
And
yes, without without any further thinking, you can apply it. Perfect use case.
okay. And one more question, that
Yes.
whether the difference GMM will be applied or the system GMM will be applied, but how to
Anirudh,
determine that?
did you join it later or in the beginning?
No, in the beginning only, you
Okay,
told
so
there are
you
certain
know,
extent
so you
system.
know how you know how to apply system or GMM. You have to do that process, okay?
Okay.
And then you will know. But I'm telling you, for all the people who are not like really very much into econometrics and all, okay, if you don't know which one is really suitable in your case, you can actually go directly to system GMM, because
Yeah, that's an upgraded one.
system GMM is an extension of difference GMM. So system GMM is more efficient than difference GMM in any case. Okay.
Thank you, ma'am. Thank you so much.
Welcome.
So next is like Priyanka. You may ask your question, and after that we'll move to like Stata.
Okay.
Hello, ma'am.
Hello, Priyanka.
Ma'am, in my data set, one dependent variable and 6 independent variable, then
Okay.
we can apply GMM or not?
You can apply GMM, but what is your time period?
Time period is around 18 years, ma'am.
Time period is around 18 years, and you have 6 into
6 into and 32 forms.
Yes, you can.
Okay, ma'am. Thank you, ma'am.
Welcome.
So like, ma'am, let's move to the like Stata thing which you are showing us, and then later on, if we get the time, we'll take up the question. So if you have any query, just keep your hand raised so that if we have time, I'll take it one by one.
Or maybe you can type your query perfectly.
Even I'm going to release one Google form also. If some query is already like if we missed, you just put it there and I'll share it with ma'am, and so that we can cover it maybe tomorrow in tomorrow's session, or we'll share it via mail, the answers of that. Yeah, so we'll share the Google form soon. So ma'am, let's continue with the Stata demonstration.
Yeah, I really want to do basic hands-on training on a Stata today, so that you can really practice and get familiar with the Stata. So when we move to tomorrow, if you have any problem, I'll take them first and then go to Stata. Okay.
Yeah.
Just a minute. Now, let me open Stata again. Is it visible to you all?
Yes.
Okay. And I know your I told you already, your Stata is not going to look like this. It will be a clean Stata. I have already run various commands, okay, so that it saves our time, but I'll do it one by one now as well, okay. So first command that I have to use is basically clear. So if we use clear command, okay, we clear anything that is previously estimated. Now starting from what we have to do, all of you have that data, you can do it with me. First thing that I want you to do is basically open a log file. What is the relevance of log file? I'll tell you. Okay. So if you see in the file drop down menu, we have log. Okay. Let's say log begin. Now you have to save. Okay. I give it a name of, let's say, workshop 1, 2. I don't know how many workshop file I have. So I'm naming it workshop 1, 1. And please be careful. There are 2, 3 options here. Save your log file as .log, not as .smscl, because you will not be able to read it properly. And .log you will be able to read in a notepad. Okay. So it is easier for you. So save it like this. Okay. So this is our log file is open. So what is basically the relevance of log file? If you are making a log file, it records all of the commands that we run. So in case later on you forget those commands or you have to practice, so you can really open your log file, okay? See those commands, copy them, paste them, run them, okay? Easier for you. I could have given you a do file, but in the do file you will not learn. Do file will automatically run all the commands. So better open the log file, okay, and record all the commands. So all of you, please do it first, and then we move further. And let me know when we can move. It is here. If you see file, log, begin. I have already opened, so my begin is not working. And then you choose the name as .log. Okay, type as .log and then open it. Okay, fine. So people are saying I should move further. Let me move further. Okay. Keep on telling me when to move. Okay. Maybe the time is coming to an end, but I'll take 10-15 more minutes so that you learn. Don't worry about it. I hope you have that time. Okay. So now, all of you were asking how to open the file. So if we go again to the file drop-down menu, see first open. Okay. Which you have, which you should not be using, because in open file you can only open the files which are made in Stata, but we generally use the file which are made in Excel. Okay, so what we use is basically import. So you can import any type of file. If you see a text data, an SPSS data, SAS data, ODBC data, text data in fixed form, okay, you can use it. But most probably, most of the time, you will be using Excel spreadsheet. So we work with Excel spreadsheet. Import Excel, and then we browse. My file is on desktop only. So I'm selecting it from there. And you see here, if you see, it will show you all the worksheet listed. Okay, 1, 2, 3, 4, 5. Okay. Now, I want to show you data file is already available to you, but I want to show you also. Now, because you have first row as variable name, so please select this, import first row as variable names, and say okay. Now your file is here, and if you see in the side, we have three windows already open here. I'll tell you what are these windows about. This window is basically history. It gives you command history. So if you are anytime using a Stata, and sometimes we run so many commands, like you were saying, if we don't have validated instrument, then you have to run again and again. You can really open your command window. You can again use the command from here. Okay, like for example, I said import Excel, but I want to not use it now. First I have to clear it, but if I clear it, my log command will also be cleared, so I'm not using it. But I'm telling you, if you have to use any command from the history, you can just go like this. Like let's say I have clicked it here, it is available in the command window, we do it. Okay, and also on the right hand side you will see the variables list. Okay, you can select your variables like this in your command. Okay, or you can type, anything is fine. And this is your result window, the main window. Now we have learned two things: how to open a log file, how to import your Excel file. All of you, are you clear about it? Shall we move further? Okay, I'll tell you how to write the command, don't worry. But if you see, till now we have not written any command. Okay, so when it is a time, I'll show you how to write command. So now, if you need to see what is your data looking like, so there is this data. So you go to the data drop down menu, you go to the data editor, you can browse your data. Okay, I have opened this file. What do I have it? Originally downloaded data from, let's say, CMI progress. Okay, this is just for example. So I have not, shown you the full data in this original file. So if you have to change any data here, what you do? Edit. Okay, when you do edit, you can change it. Like let's say, maybe we need to go back to the edit, not to the browse. Just a minute. If you have to edit data, so there is the data editor. So you go to data editor, edit it here. Let's say I put 1 2 3 4 5. It's edited. So you can also edit your data in the Stata. So now we basically don't need this file. We need to we have to make actually the panel data. So this is just for showing you how the data look like when we have not make it in panel format. Now we start making panel data. So I have to first clear it. Okay, and let's say import the file again. Okay, and now I'm importing the worksheet on total income. Okay, and if you want me to do, if you want me to do it from the drop down menu, I'll do it from there. I understand. Just a minute, I'll go back there. We do import Excel spreadsheet, browse the file again. It's on my desktop, it's here. And then I have to change my data sheet. I import total income, import first row as variable name, and okay. So I have imported it. Okay. Now we are going to run one command for reshaping our data. Okay. This data is also available to you in the last worksheet. I have given you the downloaded one as well if you are not able to do it, but now let's do it. So first thing is that we need to reshape our wide data in the longitudinal data to use it as a panel. Okay. I'm showing you it variable by variable, so it is easier to understand for you. So the command for this is basically reshape. Now you ask me, if you don't know what is the command, how do you know about it? So Stata has a very powerful feature for that. This feature is called help. Okay, and it really helps you. let's say we know the command is reshape, because you can do a really simple Google search how to make panel data. It will tell you the command is reshape in Stata. So you come here and do a keyword search. You know reshape, just type it reshape. Stata is going to search for you all the documentation, all the net sources. This is one feature I personally think makes Stata better. Okay, everything is available on your fingertips. If you really don't know Stata, you can learn it totally with this help command. Okay, so I'm searching it for you.
Excuse me, ma'am.
Yes, tell me.
Your pop-up screens are not visible to us.
My pop-up screen is not visible to you.
Yes, ma'am. We cannot see the pop-up, and whatever the steps you have done from the drop-down, it is not visible.
It is not visible. Okay.
Ma'am, last 5 minutes discussion we have missed totally because we haven't seen the things.
No problem. I'll try to do it again. Is it visible now? Is it visible?
Ma'am, your screen is visible, but whenever you are opening some pop-up screen, that is not visible.
Okay.
Yes.
The pop-up screen is visible to you now or not?
No, ma'am, the pop-up is not
No,
visible.
once you go to the file.
Ma'am, you can
Once you
any
go to the
activity
file,
that you are
entire
doing on
picture.
the screen. Yeah, any activity that
Ma'am,
you are
can
doing
you
on the
share
screen.
your
is
entire
not
screen?
visible.
Can
What are you saying?
Only
Can you share your entire screen?
I have shared my entire screen actually. That is the option
Ma'am,
that
once
I
you,
have used. That is
ma'am,
entire
once you go to
screen.
the file, once you go to the file, import, so on, that's not getting visible. So we are not seeing that screen. That's how it is. Yeah. Yeah, that's we are
Are
not
you seeing
seeing.
it
We
now?
are-
I am in file
No.
open. Now tell me one thing. I am using the file drop down. Are you able to see it or not?
No.
No, ma'am.
Shilpi,
No, ma'am.
No.
No,
That's
ma'am.
the thing.
So maybe like you can reshare the screen again with the option is share the entire screen. So we
I
will
have
be
done
able
it
to see.
again also. Let me do it again. No problem. So see, I stop using the data. Okay, stop presenting. No screen is here. I use it again for the entire screen. Just a minute.
You need to select the last option. The
Yes,
entire
I know. I need to select the last option. This time my screen is not visible to me also. Okay, I'm trying to just figure it out. So if I go back there, I also am not able to see my screen. Okay, it is here in the window. Okay. So if I select the window now, I'm selecting it. Okay. And sharing it.
It will select. It will not
Is
show.
it visible
You
to
have
you now?
No, ma'am.
No.
Yeah, screen is visible.
Now it's visible.
It's visible, but I don't think like file if you'll pop-up will show.
So
Only
that
through
might
the
be
entire
that might be a thing with Stata because pop-up is in the another file. Okay. Just a minute. Let me just do one thing. I'll try to minimize these windows and try to open if there is any pop-up on the side. There is no pop-up right now. So let me just tell
Maybe,
me.
ma'am, what you can do is just give everybody the steps so that we can go to the next thing.
Okay,
We have
fine.
imported the data.
Okay, fine. Can you see my screen now?
Yes. Screen is visible. The only problem is the pop-up.
I understand. Now what I'll do now, I have done Stata little bit in a small window. If there is any pop-up, I'll open it on the side. Okay, so that it is clear to you. Fine. Now, just tell me. I clear the commands again. I'm using the file import again. Just let me know. Now the pop-up is visible to you or not?
No,
No, ma'am, it's not
No,
visible.
ma'am.
It's not visible. And I'm placing it on the side really, but it's not visible
No.
to you.
So the cursor can be seen, but then all the tabs are not visible to us.
Okay.
Ma'am, if
Fine.
you share the entire screen, then only we can see the pop-up.
Then only it will come.
Okay. Fine.
If you share just window, so only we can
I
see
know,
this.
I know, I know. I'll do it again. I hope this time it will work. Is it visible to you now?
Something is coming up. Yes, yes,
Yes, ma'am.
yes.
Ma'am. It's
Pop up
visible.
on the side.
Yes.
And also the screen.
Yes, screen. You just not click one time on the file. We will also like get to know if that is showing or not. If you
Okay,
can
fine.
hit on the file option.
Yeah, sure. So this is clear.
Yes, it's
Okay.
visible.
Everything is visible. Now I click on file. Okay, but I have already opened it. I have to close it now. File.
Yeah.
Import.
Yes.
Excel
Yes, ma'am.
spreadsheet. We browse it from the desktop. I was telling you about total income. I'll just take now total income. Import first row as variable name. Okay, because we have given it as variable name. If you don't do it, it will not read your data as variables. Okay. Now we have imported it. If you want to see where we can see it, we go to data tab. Okay. And let me open it fully now. You can go to data tab and then you have data editor. You can use data editor browse to browse your data. So this is the data basically in TI file. Okay. Can you see it now? Is everything perfect?
Yes, ma'am.
Yes.
Yes,
Yes.
ma'am.
Okay, fine. So now you see TI data, but you cannot, you see it's not in panel because it's just one variable. So first thing we have to do is make it a panel, okay, from one variable. So we have imported one. I am going to use now the reshape command. Yes. So now I go to reshape command. I was telling you one of the most powerful feature of a Stata is basically help. Okay. So if you know this is the command and you ask me how I will know about the command, if you do simple Google search on how to make panel data in a Stata, it will tell you have to reshape. So if you know reshape and you don't know its syntax, so you can just type it in a Stata. Okay, let's see. So it gives you, now the screen is with you. You can see it is telling you about entire reshape, how to use it. Convert data from wide to long. It is also telling you the syntax, long data looks like it, wide data looks like it. You can reshape wide stub j. J is your existing variable from wide to long. So it's telling you everything. Okay. It needs a bit of practice to understand what you have to do, but it will help you anyway. So now we have to reshape. So I'm going to give a command now. The command is, if you really want me to type it, I'll type it also. Reshape is the command. You were asking how to type it. Simply type it, reshape. Okay. Long, because we have to make longitudinal or panel data. Our variable is TI. Because if you see the data, I'll show the data again to you so that you understand how it works. I have given TI for every year. So it will pick it from here. Suppose you have written, let's say, XYZ here. So if you have written XYZ here, then you have to write XYZ after long TI. So whatever you have defined here, you will write. Now we come to two things. This is your variable, which you want to make it in the longitudinal format. I here is your ID. Okay. ID is what? ID is your firm here. Or it can be your country. So we have given it an ID. Okay. 1, 2, 3, 4, 5. It does not make any difference to Stata if you give it in alphabets also. Okay, it will take it. Now there is J. J is for your time variable. So here time variable we know is a year. We have taken it in the format of year. It's a yearly data. Okay. So now we run this command reshape long TIIID J year, and it gives you data changed in the long format. So from number of observation from 157, we have now 2355. Let's see it, how it looks now. Data editor, browse. You see, now it is in the longitudinal format. So what you can simply do is maybe just copy it from here like this. Okay, select copy. I use this option most of the time. And this is the same data, but if you want me to really show you, let's go here. We can just copy it here. Okay. So now we have our first variable for the panel data. In the similar manner, we can make other variables as well, convert them to or reshape them to, let's say, longitudinal format. After this command, see, if you have to open another file, okay, whenever you are importing another file, you always have to use command clear. Okay, type it clear because it clear the data from the memory, then only you can import new one. So I typed clear. Now we again import another variable. Let's say import browse workshop data, and now I go to, let's say, ROCE. Okay, import first row as variable name. Okay, done. And now what we do, we have to use reshape command. Same thing, ROCE in the beginning. Then we have I for ID, J for year, run it. Okay, it's telling you how your observation is looking like now. We go to data, browse it, copy ROCE. Okay, in your file, we are making our panel data. Okay, so you can do it like this. I have already done it and given to you. If you see, this is the panel data file, but I have also generated another additional variables here. So this is your complete panel file. You should also try and make a file of this kind. Okay, repeating this reshape command again and again, and also importing your data here. Then I want to talk about two other things. Let's say now I finally import this file. Okay. Okay, I'm importing the file that is named as panel data file in the datasheet. I'll show you which file is that, this panel data file. Okay, I'm importing it. We have our data in the panel format. You can really see it. Here the ID is given 1. So this is one from 5 flavors of specialty restaurant private limited. Then we have here 2009 to 23. This is our TI variable, ROCE, RM, ACE, MS. Okay. So this is how our panel is looking, but we want to make additional variable now. Like we want to make leg of T1 and T12. Okay. So how can we make this variable? Let's say in Stata. Okay. So first thing is that before we make, what are the important commands that we can use? One command is that we can use is sum. Sum is a short for summarize. You can either write summarize like I'm writing it here. Okay. Or you can write sum. Both gives you the same. Okay. So we have summarize and sum. What does it give us? It gives us the descriptive statistics. Okay. You can use this table to describe your descriptive statistics. Okay. Now, first thing that you have to do before running any panel model on your data is basically declare your data to be a panel data set. So for that command is xtset. Okay. Xtset is your command. You have to use ID because on the basis of ID, you will make a panel, and year is your time variable. And you have to only mention what you have taken. So we have taken year. So we will mention it as, ID and year. And now I run it. It tells me first thing that it has done is declared our data set to be the panel data set. Second thing is that your panel data set is strongly balanced. Okay. Time variable is 2009 to 23. Okay. So now you can run any command on any of the panel data model on this data. But until or unless you declare your data to be, as a panel data, you cannot really, uh, run a panel data model. So first thing is that you have to declare your data to be panel data by using xdset command. There is one more command that we sometimes use, but we don't need in this case, but I'm telling you because our data is already sorted. Otherwise, you can use sort ID here. It will sort your data. But we have done it, and also I have typed it wrong. So one thing is that you have to be very clear about, your capital letters or small letters, because Stata also read it like it is given. So it will also sort your ID to year, but our data was already sorted, so it has not changed. If now you want to see your panel data, go to data editor, browse, and just, you see, it's a perfect panel data for you to use. Now, additionally, I want to show you two more commands, and then I'm done. If you have to generate lagged variable, one thing I want to make clear, if you have to use lag dependent variable, it is already available in GMM structure. For that, you don't need to use lag, okay? But here you have to type generate command. Either you write full generate, like I'll write here, or you use gen. You can actually use first three alphabets of any command, and it works perfectly fine in the Stata. So generate, I have given the variable name of lag ti1, okay? Generate lag ti1 for the variable ti and make it n minus 1. So what you will see now, if you go back to data editor, browse, let's see, it is our lag ti1 variable, okay? And similarly, you can use this command to generate, let's say, lag of 2, lag of 3, whatever you need, okay? Now, sometimes we have to make dummy on other things. Let's say I want to say, it's not relevant for this data if you ask me, but I just want to show you. I want to say that there is an energy crisis, okay, in some year, and I say energy crisis year was 2013, and it is going to impact our dependent variable. So I want to make a dummy order. So I write generate ecdum is equal to year greater than 2030. So I run this command. This name I have given, you can give any name. But the command, if I am taking the years after 2013 as one, so I have to write syntax as year greater than 2013. Press it, and it has generated that command also. You browse it, and you see it. ecdum, it is here. Okay. Now, these were the basic commands, okay, which I wanted you to know. You can also make very beautiful graphics by using a Stata, which you cannot really make in, as per my limited knowledge, you cannot make them in, let's say, in Excel. But maybe, I'm not sure, because I never made those graphs in Stata. Sorry, in Excel, only in Stata. But if you want, like, you can make a two-way graph, okay? Let's say plot, create. So I want to have a fit plot. Okay, so I choose one variable, which is our dependent variable here, ROC, and X variable, any variable I'll choose. I just want to show you RM. So, so now I have to accept and submit. Okay, submit. See, you can have this kind of graph. On the y-axis, you have ROC. On the x-axis, you have repair and maintenance as RM. These kind of graphs help you to understand the direction and magnitude of your coefficients. Sometimes you have the coefficient, but estimate is not really telling what is the direction, because it tells you the direction. But if you see this, no estimate can tell you about this beautiful inverted U structure. For that, you have to plot these graphs. So I wanted you to see one option here, okay, which is more than available, extra feature that is available in the Stata. So now I think this is all from my side, but don't forget to close your log file. If you don't close it, you lost it. It's not saved. So you close your log file. I have closed it. And now if you want me to show you the log file, okay, Just a minute. I'll go back to the log file and show you. I don't know where I have saved that log file. But all of you have made that log file. So you can really see your log file on the screen. Okay. And close your log file. I think this is all from my side for today. Today, when you have time, please try to run these command. Also, if you are really interested, you can go to statistics. I'm telling you, go to panel data. Okay. This is dynamic panel data that you are all interested. This is Arlano bond estimation. You can try to, just get a little bit familiar about with it if you want to do it. Otherwise, also we are going to do it tomorrow, not today. Okay. So now, thank you all from my side.
Yeah. Thank you, ma'am. I think we have just
Thank you.
one query left for today, if it is okay with you.
Yeah, sure.
Yeah. So Mansi Chaudhary, you may ask your question. Maybe we have already. I think she has already.
Okay.
No problem. So thank you, Shilpi ma'am. Yes, ma'am.
Thank
Please.
you, everyone. And in case you have any particular query or something, please let the coordinators know about it so that I can take in tomorrow's session. Okay.
Yes, ma'am. We'll share it. We'll share the queries with you, whatever we receive. And tomorrow, same time.
And please don't really write your emails, because in any case, I will not be able to write 100 emails. Okay. If you have really important one, please share.
Yeah, but we'll share definitely.
Yeah, please
You
share
share
the
with this.
recording so that we can.
Yeah, sure,
practice.
sure. Yeah, definitely we'll share the recordings and other notes.
And thank you
so
everyone for your so much of interest in the GMM model. I really appreciate you asking questions and listening carefully.
Thank you, ma'am.